Okay, now let's see this question. This question came in GATE 2016 for 2 marks. The question is G is equal to V comma E is an undirected simple graph in which each edge has distinct weight and E is a particular edge of G. Okay, which of the following statements about the minimum spanning tree of G is or are true? The first statement is if E is the lightest edge in some cycle of G, then every MST of G includes E. And the second statement is if E is the heaviest edge of some cycle of G, then every MST of G excludes E. Okay, so E is what? E is any particular edge of G. And about E, these two statements are given that with respect to a minimum spanning tree of MST, minimum spanning tree MST of a particular graph G, which of the statements are correct with respect to any particular edge E? If edge E is lightest and if edge E is heaviest, then what are the things which we are expecting to happen? See, if E is the lightest edge, then in some cycle of G, then every MST of G includes E. Now, actually, this statement is false. This I can show you by a counter example. How? Let's try to understand this graph. See, let's say there are 4 vertices and it is a complete graph, so it has 6 edges. Now, let's say this edge is 1, this edge is 2, this edge is 3, and let's say this is 4, this is 5, and this edge is 6. Okay. Now, see, this 4, 5 and 6, these edges form a loop, right? But when we try to find a MST, we are having MST something like this. So, see, this is a MST, it covers all the vertices. Now, this is a loop and E is the lightest edge of some cycle of G. So in this cycle, the lightest edge is this. Then every MST of G includes E. Now this is an MST which includes edges 1, 2 and 3, but this MST does not include 4. So this statement is false. Now let's come to the second statement. If E is the heaviest edge of some cycle of G, then every MST of G excludes E. Now this statement is correct, so we cannot have a counter example. So the only way is to prove that it is correct. But here I would like to tell you one thing, that this is a difficult question actually. So if you are already knowing this fact, then it would be easier for you in the exam. However, if you don't know this fact, then in the examination hall itself, it is difficult to come out with such an intuition and to come out with a particular way that how you can justify that this statement is correct. But for the sake, here I'm going to explain to you that how the intuition is there so that this statement is correct. Let's consider a graph something like this. So let's say in a graph there is a cycle and there are some, like, say, other parts of the graph. Okay, so let's say these are other parts of the graph. We are interested in this cycle. So let's say a particular MST is created in this graph. So let's say this edge is there in the MST, this edge is there in the MST, and in this, whatever the other edges are coming, let's say whatever these edges are there in the MST. So overall this MST is formed. Okay, now what I am talking about is that we will try to come up with a situation where we will see that okay, what happens that if this statement is correct, then if we are trying to have a situation where this heaviest edge is not excluded, that it is there in the MST. In some cycle of G, there is a particular edge which is the heaviest, and if we say that okay, that edge is not excluded, that edge exists in the MST. And by assuming that, if we later come to a particular contradiction, then we can say that this statement is false. So let's start by doing that. So in this loop, we are focusing on this loop. In this loop, let's say the edges are something like 7, 8, 9. Let's say this is 7, this is 8, and this is 9. And I have chosen the edge weights in such a way that, see, E is the heaviest edge in some cycle of G. So in this cycle, the heaviest edge is this 9. So the statement is saying that it must exclude E. Let's see, and let's try to firstly establish that, okay, what happens if the heaviest edge is not excluded, rather it is in the MST. So this is the MST which we are talking about, in which 7 and 9 both are in the MST. Now see, what we are going to do is that we know that in MST, if we add one more edge, then it will form a loop. Okay, so let's try to add a particular edge. Now we are going to add this edge. So let's add this edge in our MST. Now addition of this new edge will form a loop. Okay, now this edge, which is the highest, which is the edge having the highest weight, if we remove this from the MST, so let's say we are removing this from the MST, then so addition of a new edge in the MST created a loop, and we can again come back to a tree when we remove this edge. Now once we remove this edge, we know that the rest of the structure is again a tree. But we see that earlier, whatever the cost of the tree was there, now we are again getting a MST, we are again getting a spanning tree, but its cost is smaller than the previous one. Earlier the edge weight was whatever weight here, W1, W2, W3 plus 7 plus 9. This was the weight of the entire spanning tree, right? But now the edge weights are whatever the weights are there, W1, W2, W3 plus 7 plus 8. So our earlier assumption that earlier tree was a MST is now violated, since we are now coming up with a new spanning tree whose weight is less than that of the earlier one. So it gives us a contradiction, and it shows us that our earlier assumption was false. So this must happen, and that's why this statement is second statement is true, and the answer is 2 only, B. But again, this this fact is actually not very easy to come up with directly in the examination. So if you know this fact already, then it is good. Otherwise, I have given you the intuition. The answer is 2 only, B.